Hi, and welcome to the NASSCO Safety Podcast. I'm your host, Dennis Piven, and today I have with me Mark Gaines. Welcome, Mark. Mark works with Archview Services. Mark's got 20 years in confined space and fall protection experience with 30 years in safety product development. So, Mark, welcome.
Thank you, Dennis. Glad to be here.
Thank you. Today we're going to talk about and discuss equipment in confined space and how important it is to our industry, right? So there's 5 critical components that we talk about. It's in the NASSCO confined space video, and I know you and I have done some training together, and we hit those 5 critical components. So let's start there. Let's kind of walk through that with our audience.
Of course. Well, any confined space, the first thing we need to do is make sure that the atmosphere is clear of any gases. So we're going to do air monitoring. And we can also use our blowers to purge that confined space. So we may actually want to set up our blower prior to that. And then we need to make sure that we have our safety gear, harnesses, and our tripod and equipment like that. And that includes our rescue equipment as well.
Okay, and then also the permit. We want to get through that permit.
And of course, we're going to need a permit once we have done our air monitoring and checked that, and we have purged that confined space. We're going to do another air monitor and make sure it's clear before we go in. We'll document all that information on that permit.
Okay, so just to recap, I'll recap it for you. So we have air monitoring, we have ventilation, right? So
Correct.
air monitoring, ventilation first, confined space permit, fall protection, right? And including the harness.
Correct.
So we consider those 5 critical components. So let's go back now and try to drill in from an equipment perspective. What are the specifics in each one of those? So we'll start with air monitoring. You've got a lot of experience with various types of air monitors in this industry. Walk us through, what do we need in underground infrastructure? Is it a 4-gas? Is it a 5-gas? And then what sensors do you recommend should be in that instrument?
There are many different types of monitors out there that measure different compounds and gases. In a typical confined space area, we're looking for 4 particular gases: oxygen levels, explosive gases that may be present, any kind of mechanical exhaust, CO gases that may be down there, and then also common gases we know in the sewers that may leach up through vaults and sewer lines, H2S. We also have, for confined space monitoring, we have instruments that you can wear. Gas passes over the sensors. That's a diffusion model. Mm-hmm. Or we have a pumped version, and we'll have a hose at the proper length of the confined space entry that we can check the gases going down before entry. So when we do that, there is a procedure or a way that we're supposed to monitor that confined space. We want to lower our hose with our instrument while we're looking at it and taking the readings.
So you got the hose attached, so you've got an external pump on this instrument that's pulling the air out of the manhole.
Which I'm glad you brought that up. Most instruments are going to have either a pump built in that continuously runs, and that uses up battery life. Some instruments have an external pump, and then some manufacturers allow us to turn that pump on and off. So, but as long as we have a pump monitor, our gas detector, we have that hose attached, as we just discussed, and we want to start by going down in increments of about 3 feet.
Okay.
And depending on how deep your confined space is, make sure you have the appropriate length hose. And we're going to hold that line at 3 feet for anywhere from 1.5 minutes to 2 minutes. And we're going to go down another 3 feet and monitor that for another 2 minutes. And we're going to do that every 3 feet as we're going down. And we want to make sure that we're monitoring air levels from the top, mid-levels, all the way down to the bottom. Now, when we get to the bottom, if you know there's liquids down there like water, you don't want to suck the water up into the hose and ruin your instrument. So make sure you do, or you have your filters on the end of your tube as well. But once you've taken those readings and you have the all clear, then we can make sure, or then we can go ahead and fill out our permit with the readings and the results that we had.
Right, right. And the reason we're measuring that gas, the top, middle, and bottom, is because a lot of these gases have different vapor densities. Some will stay low in the manhole, some will
Correct.
be in that middle range, and some will rise at a higher level. So you cannot assume that because you drop a hose into a manhole in one location that you're measuring all gases.
That's correct.
And that's one thing we try to drive in our training, don't we? Is just try to educate them to understanding that. We won't spend a lot of time on this podcast on vapor density, but it's important to understand the gases. You mentioned the 4 sensors that are typically in the air monitors for our industry. That's great. And then there are occasions when you might need another sensor if you're working in an industrial plant, for example, methylene
Right.
chloride, right? So what are some of those sensors?
So we also have instruments can be designed and configured from 1 to 5 gas, 6 gas, 7 or 8 gas, depending on what model you've selected.
Okay.
We also have what we call exotic sensors, and those might be the chlorines and ammonia and some of the other exotic chemicals used on these sites. And we also have actually a PID sensor for VOCs that we can measure and have in our instrument.
So PID is photoionization detector,
It is,
and that'll measure volatile organic compounds,
correct.
right? And you calibrate it to isobutylene in most cases. And so that way you can detect toluene, for example, or xylene or styrene or something like that, right?
Right.
Okay.
And you brought up calibration. It's also good to always do test your instrument prior to use. So we call that bump testing. So you can apply some of the gases that we're looking for and make sure that our sensors go off at the low alarms where they're supposed to go off, and verify that all those sensors are working properly.
All right, let's do a little more of a deep dive there, right? Because there's a difference between a bump test and a calibration.
Correct.
And I think it's important for our audience to hear from you on the differences between the two. So let's start. What's a bump test?
So our bump test is just going to verify that our sensors are reading at the set levels that have been inputted into the sensor technology.
Okay, now compare that to a calibration.
A calibration is going to do an actual span on your sensors, and normally we're going to zero out these sensors and create a baseline, and then we're going to calibrate it with the gases that we're looking for. And we have, multi-gas combinations, what we call quad gas, and those are typically your O2, CO, H2S, and your LEL, or your explosive gases, methane. And then if we have other sensors, for example, if we have that built-in PID, we're going to have our isobutylene calibration gas. And then the same would be for if we're looking for any kind of exotic gases, ammonia, chlorine, or some of those others that might be present. But we would have to actually make sure each sensor is reading at the preset levels.
Okay, good. So we differentiated bump testing from calibration. I think that confuses a lot of people. We've covered air monitoring pretty thoroughly here. Let's move on to ventilation, right? A lot of different manufacturers of ventilation equipment in the market. When we're doing confined space training together, I know we both talked about this, we kind of like higher ventilation, 1,800 cubic feet per minute. So we're pushing more air into the space, right? So talk us through what that looks like in a typical confined space for underground construction.
Well, using ventilators, there are different CFM ventilators out there. We want to have about 7 to 8 air changes in any given space per hour. And you also have to take in consideration any bends in the hose. And we have adapters to help bend that hose, but you're going to lose CFM at that as well. But we want to make sure that we got the proper CFM required for the size of that confined space area, and allow for any of the bends that we may have in there. So in some cases, you may have to get a second blower if you got multiple bends in the line.
Okay, all right. So we've talked about it. Ventilation isn't all that complicated. You just have to do it.
Right.
Right, and I know that's sometimes a challenge, especially if it gets super cold and you're working in some of the coldest parts of the country. You're blowing cold air on top of your neck and your back when you're down in a manhole. That's uncomfortable, but you got to do it. You need the ventilation. It's a critical part of confined space. The third component is the permit. And when you and I talk about this in training, I thought I'd bring this up. We compare it a lot to the airline industry. What do the airline pilots do, right? They're always checking that plane when they land and before they take off. And isn't that similar to what we do with confined space permits?
Our pre-checks.
Yeah.
Make sure everything's operating properly and we have no issues or gases present that.
So we're recording the gas levels. That's one thing on the permit, but it's a checklist for all things rescue, equipment, air monitoring, right? It just really gives us the detail on that.
Walks you right down the list of what you need, including all your PPE. Times and dates is important. And then we normally have to have our supervisor, manager in charge sign off on it.
Right. And then we close it at the end of the project. We close those permits, so we're not leaving anything behind.
Correct.
Everything's detailed and checked out. All right, now let's move on to the harnesses. It's a critical component. It's one of the 5 critical components that these workers that are going in confined space are wearing harnesses. And you've got a ton of experience in this space. So walk us through harnessing.
Well, our fall protection is going to be treated just like we would any of our fall protection equipment in general industry or underground construction. So we must have harnesses that fit us properly. We've had people with the wrong size, our workers with the wrong size harness that have had issues. If your harness is too big and you can't cinch it down properly, we could come out of the harness. There's different size harnesses. There's different harnesses for rescue. We have construction style harnesses. We have your basic general industry harness. We even have harnesses for women. And we also have had harnesses that are universal in size, which really isn't true. Universal size harnesses may be simple or easy to order, but the small guy using a universal size harness may not be able to cinch it up properly. And the tall, lanky guy may not be able to get a good fit either or even get it on properly. We have sizing charts that go by height and weight, which tend to be very accurate, with the exception of somebody that has, odd shaped body maybe. But it's very important that when we don our harnesses that we do our inspection prior to use. So that is taught through awareness training. All new employees should have awareness training and go through all their fall protection equipment, the ABCDs of fall protections: anchorage, body support, connectors, descent and rescue. We're talking more about descent and rescue now, but we still have to do our due diligence, inspect prior to use. And then there's specialized harnesses for confined space entry. Traditional harnesses have a back dorsal D-ring. Confined space harness is likely going to have a front sternal D-ring for descending and ascending with a winch. Mm-hmm. And then we also may have a harness with the front and back D-rings with shoulder D-rings for rescue.
Okay. I think we've covered harnesses pretty thoroughly there. Let's move into SRLs and winches, right? That's the 5th component of that confined space entry. Walk us through, there's different types of winches and cables and SRLs. Walk us through that.
Right. So we, our winches are going to be our personnel winches, and there's also material winches. So it's important to understand that some winches are designed to lift equipment, and other winches are designed for personnel.
And you can't switch the two.
And you can't switch the two. The personnel winch should only be used for our workers and our personnel. There's different types of cables. We have stainless steel cables. In a confined space, you may have moisture, humidity, corrosive gases, H2S, may leach up into a bolt or your confined space, and it's very corrosive, as we know. Mm-hmm. So we like stainless steel for that, but we have galvanized steel, and we can use the galvanized as well. We just, it may not last as long. But we're going to do inspections prior to use on all of our equipment. But winches and our SRLs, well, let me say our SRLs, we have 2 types of SRLs. First, we have a Class 1 and Class 2. Class 1 SRL is our connecting point has to be overhead above that back dorsal D-ring.
Okay.
Our Class 2 allows us to tie off as low as foot level. and it also provides leading edge protection. So on a Class 2, you're going to have a shock absorber in line on the cable, and if you go over an edge and there's a sharp edge, that shock absorber is going to protect you from that cable cutting in half.
Okay. Let's talk about this for underground infrastructure, because we do a lot of descent into manholes, but then there's horizontal entry. Now we got edge protection issues, right? Because that cable is going to be running up against whatever the hose pipe is for that. So
Correct.
what do they typically use for that?
So we have a thing we call edge softeners, or tiger tail.
Okay.
It's basically like a vacuum hose that's going to be a 4-inch diameter that we can run the snap hook and the cable and lay that tiger hose or that edge softener right on that edge to protect that cable.
Okay. So there's a way to provide some level of protection on that cable. Yeah,
Correct.
I love it. All right. Well, we've covered those 5 critical components very well. You've got 30 years experience in this field. You've seen a lot of changes. Kind of give us your take on what have been some of the positives that have happened over the last 30 years in equipment for confined space.
Well, one of them for confined space was the SRL with a built-in winch. We call that a 3-way SRL,
Okay.
or it could be called SRL/R for retrieval capabilities. So if you see that SRL/R, that means it's the 3-way. And it's essentially a SRL that's designed for fall arrest. When you fall, it's going to lock up like the seatbelt of a car and all our other SRL devices. But you also have the capability in event of emergency, if my winch fails or the ladder fails, I can crank them up with the SRL. So just in case there's an emergency.
Yeah, and I unfortunately had that happen to me a few months ago in a training class on the winch, right? We were in a simulator and we were pulling a worker out of the confined space. The winch cable overlapped and bound up the winch. So we immediately switched over to the SRL/R, and we were able to finish pulling the employee out without a hiccup. So it's a great tool when you need it.
It is,
Right.
and I'm sure that the guys on site during that training looked at that and said, wow, that's really neat to have that backup.
It is, because it's rare that that winch will do that. I don't want you to think that's a commonplace, but it can happen, right? We don't always know how this equipment's going to go the way we think it is, so that's great. All right, thanks for sharing with us today on all this equipment. You did, I think you've brought a lot of knowledge to our audience for sure, and a lot of your experience with this whole issue of confined space. So thank you for that, Mark.
No.
You did a great job today. Thanks for
My pleasure.
joining us.
Thank you.
I hope you enjoyed our topic for today. Thanks for joining the NASSCO Safety Podcast. For more information on safety topics, please go to nassco.org, click on Safety, and choose your safety topic.